Okay, hang on. Okay, so you are given 2 tins of soup, and then they give you the mass of the soup and the price. So which one gives better value? If you are faced with this situation where you're out shopping, I'm sure you know how to find which one has better value, right? So right now, when we mark, we want to see that you have the correct thought process. And how we are able to tell that will be based on your presentation. So can we write something like this? Like that. What do you all think? Can we do this? What's wrong with this? What's wrong with this? It's like, what are you trying to tell me? What do you mean by small equals to 0.002506? What do you mean by big equals to 0.002429? What are you trying to tell me? I've seen many good presentations. So this one is, no lah, you're not telling me much. What you should be doing could be calculating the price per gram, okay? We can calculate price per gram for small tin. So we can work this out. This is your statement. Then show me the working. Okay, so 415 grams, they cost 1.04. So 1 gram will cost 1.04 divided by 415 grams. You can choose to put in the units here, or you can choose to remove them. So you will get 1.04 divided by 415. So you get this as 0.002506. This is the cost per gram in a small tin. Then we can do something similar for the big tin. Price per gram for big tin. That will give us 1.98 divided by 815. So this is the price per gram. So based on these two, best value means we want the lowest price per gram. So this is lower than 0.002506. So now we can conclude that the large tin gives better value. Okay, so instead of saying big, we call it large over here. Don't you think this is clearer than the previous presentation like this? When I see this, I know exactly what you're trying to do, what you're thinking about. There's more than one way to do this. Some of you may be finding the 1 cent gets you how much in mass. Also can. Okay? So for 1 cent, how much mass of soup do you get in a small tin, in a large tin? So the better value will of course be 1 cent gets you the most mass lah. So you must know which one to compare, how to compare. Okay? Next, question 13. Still paper 1, question 13. Take a look at the question. Okay, so now, in this question, they ask us to find the value of t, the time taken when the depth is 12. Okay, so the total height over here is 24, right? So 12 will be when the height is just midway. But does that mean the time taken will be half of the total time, which is 8? Logically, you look at it, you know that it's not going to be the case. You expect it to fill up the height. You expect the height to rise really quickly because at the bottom, the amount of space is lower than the amount of space at the top. So you expect the height to rise quickly, then the height will rise at a slower rate as the level increases. Okay, so this is what we can just imagine, and it's logical to us. So mathematically, what does this mean? Okay, so we definitely will need to be comparing the volume of this container. The volume when the height is equals to 12 versus the volume when the height is equals to 24. So this is how I'll be doing it. The volume small over volume total. What is this going to be? Small meaning when it is not filled up lah. The volume of this prism will be given by your cross-sectional area times the vertical height, right? In this case, we can call this the width. Okay, W over here. So this will be area small times the width over area total times the width. I'm going through this question because I see many of your corrections or your answers. It's just exactly the same as the answer booklet. I don't know whether you really understand what they are doing or not because they didn't state what they are trying to find. Okay, so now I'm explaining to you the volume of the water inside over the total volume is given by area of this portion times the width divided by the area of this portion. This part times the width. Ipin, can understand? Hang on first. Can I understand what I'm trying to do first or not? So understand, huh? Now, we are comparing the small volume over total volume. We see that it is equal to small area times width divided by total area times width. So since width is the same thing, we can cancel it out. What this means is, comparing the volume when it is partially filled over total volume is the same as comparing the area of this side when it is partially filled divided by the area of the entire container in yellow color. Understand so far? Who don't understand? Which part don't understand? Ikpin and Yuling, do you understand this part? How to find the volume of the total prism? Denominator. Huh? Volume of the total container. Half times 24 times width times this one, is it? Exactly. So I ask you, what is the volume of the whole container? What length? You mean this length? So you are telling me volume of this container is half times 24 times L times W, is it? Okay, what is half times 24 times L? Area, right? Of the yellow color, right? Isn't it this over here? Then you are saying times W, right? Yeah lah. So you understand my denominator already? Okay, now let's do the same thing for our numerator. Okay, what is the volume of the water inside here now? Half times D times second L, which is different from the original L, then times W, right? What is half times D times this one? Isn't that the area of this side? In red, right? So that is this part. Then times W, right? Okay, so now do you understand what the right hand side represents? You understand? Okay, so now comparing the ratio of the volume is the same as comparing the ratio of the area. Agree? You, Yiping, agree? Okay, so now when we want to compare the area, can you tell me whether these two triangles, the one shaded in red and the one in yellow, are they similar triangles? Yes, they are similar triangles. Since they are similar triangles, what can you tell me about the ratio of area? It will be the square of the ratio of the length, right? So, what is the ratio of length? Can we compare the height? Okay, before we say 12, initially we are given as d over 24, right? Well, we can just compare the height, and we need to square it. So this gives me d square over 24 square lah. Okay? So now, when d is equal to 12, then my ratio, volume small over volume total, is equals to 12 square over 24 square, which is 1 over 4. Can follow so far? So now, we know that the volume of the water inside when d is equals to 12, the volume is actually 1/4 of the volume of the whole container. Okay? Yeah. So since the volume for the small container is 1/4 of the volume of the total container, that means time taken to reach a depth of 12 cm is equals to 1/4 of the time for it to be completely filled. So that will be 1/4 of 8 seconds, which is 2 seconds. Okay? I'm writing a lot of things down. Not everything is required because I'm just explaining. What I expect to see in order to help me mark will be this portion. These are the parts that at least I want to see. Okay, so can I move on? So this is a 1-mark question. Some of you may just see and you know what value it should be. Are they good for you lah? Otherwise, this is the thought process that you should have. Okay, I'm going on to the graph now. Part B. On the axis and answer space, sketch the graph. So we have one set of coordinates over here. When time is equals to 2 seconds, what is the depth? Yeah, when time is equals to 2 seconds, my depth will be 12. Maximum is 24. So this will be 1 point. 2, 4, 6, 8. And the other one will be when time is equal to 8, my depth will be 24. Okay, and of course, when time equals to 0, your depth is 0 lah. So I have 3 sets of coordinates. It is not a straight line. You can expect the water to be rising. The rate of change of the height is not a constant. Okay, so it is actually a curve. The height will rise really quickly at the start. Then it will slow down. And it should be a smooth curve. So this portion, check that you have these 3 coordinates, these 3 points. Your curve intersects it, and it is one smooth curve. Not 2 straight lines or 2 very obviously different curves. next question I'm going through is 22. A and B lie on a circle, center O, radius 10 centimeters. And then they gave you AOB is 2.3 radians. Find the length of the major arc AB. The major arc AB is over here. And they told us that this is 2.3 radian. So you notice that in the diagram, did they write down any unit for the angle? Do you see any unit for the angle? In the diagram, did they give any unit for the angle? No. So no units mean what? Radian. So when you answer me with angles and you don't put out a unit, what does that mean? Radian. So whenever you do your trigonometry, you don't write down your degrees, I can mark you wrong. Because you'll be radian. Because you're still so lazy to change. Okay, so your arc length S equals to R theta, where theta is in radians. Now, we want the major arc of AB, so I need to know this angle in radian, which is given by 2 pi minus 2.3. So radius we know is 10 times 2 pi minus 2.3. Okay? So you just work this out, you should get 39.831. Round it off to 39.8 centimeters. Okay? Now in part B, find two values of x in radians such that sine x is equal to a half. What is the other value that we should be considering? Okay, there are two things we need to know. First is sine theta equals to sine 180 degrees minus theta, or in radian form, we have equals to sine pi minus theta. Right? Then what about the cosine one? Cosine theta equals to negative cosine 180 degrees minus theta, or in radian form, we have negative cosine pi minus theta. Okay, so now sine x is equal to half. So there are two possibilities. Or sine pi minus x equals to half. These are the two possibilities. So over here, sine x is equal to sine inverse half. And what do we get? 0.52360, are you sure? 59, isn't it? Okay, this is in radian. And over here, pi minus x is also equals to 0.52359. So x equals to pi plus 0.5 SF first, you truncate. That means you don't care about the rest. Just take the first 5 SF. After that, then you round off. Okay, so over here we get 0.524 radian. Or this will be, are you sure? Alright, or what? Minus ah? Oh yeah. Okay, minus. Okay, so this will be 2.6179. Round it off to get 2.62 radian. So in radian, you leave it in 3SF. Okay, even though it's an angle. Only angles in degree, then we leave it at 1 dp. Yes? To write what? This one I think a bit ambiguous, but if I know the unit is radian, then I'll just write down as radian. Yes? 23. X and Y don't need to put a degree. Yes? Anybody, any other question? Yeah, just cut. No need. The next step, then you round off. Any other questions? Average. Okay, I talk about this in 21. Okay, let's go back to question 21. They are asking the average number of people per square kilometer living in Africa, part B. Okay, listen. So there is a confusion in this question, whether the number of people can be half, whether the number of people must be a whole number, so on and so forth. Okay, in this kind of questions, especially when it's like population, you're trying to find out a survey for a country. Okay, we are not too particular about whether a person can be half a person or 3/4 of a person. In this kind of big data information, statistically, just give us even a decimal point is fine for the number of people. Okay? So that is for part B, for 21. Then in question number 24, that's the next part that I want to talk about. Showing that triangles ABX and DCX are congruent. So when they ask you to show two triangles are congruent, your working must be as such. Sketch out the two triangles first. A, B, X. This is the first one. So the second triangle, I will draw same size, same orientation. And instead of ABX, we have DCX. Then I refer back to the diagram that was given to us, and I include all the dashes that you can see that tells you which sides are the same length, which sides have the same angle, so on and so forth. So from here, without doing much work, I know that I have two corresponding sides having the same length, AX, DX, and XB, XC. What is the simplest way, which is the simplest test to use now? I have a side, I have another side. So yes, we should be going for SAS, where the angle is nestled between the two sides. So this is the purple angle we want to prove that they are the same. So looking back in your diagram, AXB, in your question paper, AXB and DXC. Just use your pencil and identify where these angles are. That is what we need to prove. Okay, once you have drawn it in your diagram, in your question paper, you know that they are vertically opposite angles. Okay? So, since they are vertically opposite, we can state that angle AXB equals to angle DXC. Reason, vertically opposite angles. This is your angle, okay? Then next, for the side, AX equals to DX. What is the reason to be given? Parisha, what is the reason to be given? AX equals to DX. Given. It is given. What about XB equals to XC? Can I say common? Cannot. Why cannot? Yeah, it is different line. You cannot say common. Common means they are exactly the same line. In this case, they tell you that they have the same length, but they are different lines. So we should be saying given. Okay? Don't say, you're not supposed to be saying using common over here. So now, triangles ABX and DCX are congruent, and we have just used the SAS congruency test. Okay? So part B and part C, generally okay. Next, we shall go on to paper 2. Paper 2, question 1B, part 2. In 2009, his best time was 10% less than his time in 2008. So 2009 is 10% less than 2008. What are we comparing with? What is the original value that we are comparing with? Which year? Vincent, which year are we comparing with? Clear, which year are we comparing with? Okay, you look at the question again. Part 1B, part 2. In 2009, his best time was 10% less than 2008. So which year are we comparing with? Yeah, we are comparing 2009 timing with 2008. So which one should be your 100%? 2008. Whatever you are comparing with will be your 100%. So the timing in 2008 is the 100% timing. Okay, what is the timing? 9 minutes, 30 seconds. Do you want to use a mixture of minute and seconds? Or do you want to convert everything to minute or everything to seconds? Wait. Yes, they are asking for minute and second, but your calculation will require you to multiply, right? So if you are going to be multiplying, you have to stick to one unit only, which is either your minute or your seconds. Because time is different from your other units, your 60 seconds is 1 minute. Then it's the problem with multiplying with minute and seconds at the same time. So whenever you need to multiply with time, change them all to one single unit. Okay? So, part B, part 2, and part 3. Convert to minute or second first, then multiply, then convert back to minute and second. Okay? Next question I want to talk about is 5B, part 4, part A. 5B, part 4, part A. Evaluate the matrix F equals to C, 25, 15. Okay. So put down what C is. So you have 10, 20, 30, 10, and 25, 15. Now what is the good habit that you should have when you are doing matrix multiplication? Yeah, write down what these numbers represent. At the top, at the side, top, side. Okay, we will see how that is useful. So this represents morning, this is afternoon. And at the top we have adult and child. Down here we have the fair, and then adult, child. So if we work this out, we are going to get 70650. Okay, so what do these represent? Over here, when you do your matrix multiplication, whatever is at the top, your adult and child over here, they kind of cancel each other off. In other words, your final answer for after you do your matrix multiplication, you should not be seeing whatever I'm highlighting in yellow anymore, because they kind of cancel each other out. So what is left? What you should be writing will be over here, fair. And then this is morning and afternoon. Okay? So now I'll use another color to highlight morning and afternoon in green. And then let's use this color, fair, over here. Your matrix multiplication result is representing the total amount of fare collected on a weekday morning and total amount of fare collected on a weekday afternoon respectively. So how you describe it can be seen from all these little words that Ms. Tan asked you to write, to annotate in pencil. Because that's useful. It helps you describe what the elements represent. Okay? Then part C. Part C, you have done something similar during your matrix lesson. It is changing of the unit to dollars. Okay, that 1/100. Changing from cents to dollars. And then the 1-1 matrix is actually just asking you to add up the two elements inside F. So it is just total fare. Last question that I'm going through is number 6. B. Okay, it is a graph question. So those of you who have your graph with you, take a look. I'll just highlight some of the common issues. Plotting, generally okay. Alright, when you're doing part B, they ask you to plot the graph. Check, did you write down the equation of this graph? Equation of graph must be shown. So over here, this is y equals to 1/10, 60 minus x squared minus 80 over x. Now your answer in the answer booklet is not always complete. So I see things submitted to me that looks exactly like what is your answer booklet without all this information. That tells me that you are not thinking when you're referring to the answer question, the answer key or the solution. It is not good enough. Write down the equation. Okay? Next, part C. Part C. Use your graph, find the values of x for which blah 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 is equals to 2. So, what is the line that we should draw? Now part C, 1/10, 60 minus x squared minus 80 over x equals to 2. Y equals to 2, but do you know why? Do you know why we need to plot the graph of y equals to 2? Find the, we need to find the x value, but why are we plotting the graph of y equals to 2? No, they didn't ask you to plot y equals to 2. So how do you conclude that? So look over here, we have a graph of y equals to all these things, right? And this is shown over here. Exactly the same, isn't it? Right? Okay. Now what is this light blue color portion equals to? It is equals to y. Correct? So this is equals to y. In other words, this 2 over here is equals to y. Okay? So I need to plot this out. Y equals to 2. So that is the reason why you are plotting y equals to 2. Yes. Can. Okay. Sorry? For y equals to 2, is it? When you are drawing a graph, use a full straight line. Don't use dotted. Dotted is only for reading the values. When they ask you to use a graph to find the values, they are expecting you to draw a graph. Otherwise, how are you going to get the values of x? Okay, so draw the graph of y equals to 2. It should look like something like this. So this is y equals to 2, and you can label it as part C, y equals to 2. We can label this as part B, y equals to 1 over 10, blah, 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 blah. Okay, so after you have drawn the graph, like what your answer key has, then it didn't tell me what are the values of x. You have your graph, you know that you are trying to find the points of intersection. This is where you use a ruler and dotted line, drop it down. Drop down and tell me what are the values over here. The values should be 2.4 and 4.8 roughly. 2.4, 4.8. We can also label this portion as part C and part C. Then at the back of your graph paper, you label them properly. Part C answer will be x equals to 2.4 and 4.8. Next part D, drawing a tangent, find the gradient of the curve at 1.5, 0.44. So I'll just use another color. 1.5 is somewhere here. Draw your tangent as best as you can, as long as you can. After you draw your tangent line, you need to find the gradient of this line, isn't it? And how do you find the gradient of this line? We need to select coordinates. Show me the coordinates you are choosing. You don't have to draw the triangle, but at least I want to see this. For example, if you choose this point, x1, y1. If you choose this point, then maybe you choose another point over here, x2, y2. I want to see these coordinates on your tangent line, so that on your next page, on your graph paper, you record down the coordinates and you plug in the values into the gradient formula. So your graph is going to look like it has a lot of information, because it should have. It shouldn't look like your answer key in your TYS answer booklet. Next, part E, find the largest value of this curve. We are looking for the maximum point, and drop the line down and write down from your graph what is this value. It should be x equals to 3.4 and y will be approximately 2.5. Okay, these are the things I expect to see on your graph. Any questions? Any other questions for this paper? 7B. E. Find the area of the shaded region. Okay, do you have the area of the pentagon? Ipin? Okay, everybody look up. Problem solving. I haven't tried this question yet, but this is my thought process, which I hope you have something similar in your mind. Okay? Without looking at the previous portion, finding the area of the region shaded in the diagram. By symmetry, the shaded region appears 1, 2, 3, 4, 5 times. Alright? So as long as I have the area of those 5 parts, I divide by 5, I should get my answer. Okay? So, shaded area is equals to 1 over 5 times of all those 5 parts. Okay? Can you understand so far? Okay. Then now, those 5 portions, they are given by area of the circle, of big circle, minus area of pentagon, minus area of 5 semicircle. So if we know that this is our process to solve it, we can break it down. Area of big circle, can you do it? Did they give you the radius? Okay, you all already found the radius. So this is pi times 4.75 square. Area of pentagon. Oh, that was given in part D, 27.5. Area of 5 semicircles will be 5 times half times pi r square, where r is the radius of the small semicircle. Do you have that? Two lah, right? The radius is 2. Because the pentagon has a side of 4 centimeters, and that is the diameter of the semicircle. So this is 2. So now you break down the question, and then you can solve every part. So they give you 3 marks for this. Any other questions for your 2009 paper? Okay, so remaining time, you will be completing your corrections, submitting your homework. All of you should have your 2009 paper due today. Yeah, I need your corrections for 2009. Who needs to go home and do the corrections after looking the video again? Okay, those who are ready with your 2009 paper corrections, pass them down to the front. Otherwise, 2009 paper with corrections